Welcome to Advantech's InnoTalk. I'm your host, Mike Farian. Today, we're going to examine what I believe to be the most daunting and urgent digital transformation challenge that we face today, and that's the modernization of our electrical grid. The grid is critical to the world's economic infrastructure. Physically, it's the largest distributed electrified infrastructure on the planet. And very simply put, it is old. So at the same time, the world of electrical energy is changing dramatically, and it's outpacing the very infrastructure that supports it. So I've got two outstanding guests joining me for today's discussion. First, we have Prithpal Kajuria with Intel. Prithpal is Intel's global segment leader for smart infrastructure and internationally recognized as a smart grid expert. And Jason Shepard was Zadata. Jason is VP of Ecosystems at Zadata and is also very active in several projects in the open source Linux Foundation relating to the ability to reliably and securely scale massive IoT deployments. Prithpal and Jason, thank you for joining us today.
Welcome. Thanks for having us.
Thank you. So Prithpal, can you kick us off today with a review of the current state of today's grid?
Yeah, thank you, Mike. I think the grid was designed 100 years ago when flow of electrons were happening from utilities to consumers, homes and businesses. But last 10 plus years, a couple of things have changed. One big thing is that penetration of renewables, what I call rooftop, parking lot, solar panels, that is creating a bidirectional flow of the electrons in the grid. As I mentioned earlier, the grid was not designed for it. The second big thing is happening is the electrification of our transportation sector. In next decade, that's right in front of us, which is going to quadruple the demand for electricity. Our infrastructure was never designed to handle these two scenarios which are in front of us. And we need to rethink how we are going to manage, maintain, and operate the grid going forward.
Yeah, it's a great point. So, if I kind of summarize from a real simplistic perspective, it used to be we build a power plant in a central location close to the customers, right? With the expectation that all the energy was going to flow downhill, if you will, from source to destination.
Yep.
And now it's become just so distributed. And on top of that, with these distributed energy producing resources, they're also highly variable, right?
That's true. And I think that's the biggest challenge is that in 1 minute, it can be 100%, and the next minute it can drop by 50%, 60%, and the load will shift back to the grid. So what is going to happen is going to be a constant seesaw. One time there's too much renewables generating the power, and the next minute they disappear and the load shift back to the grid, and grid has to step up. Okay. Now it makes the life of utilities very difficult in a couple of ways. One way is that if utilities are generating more power, and then in between customers are coming and using that power, they're wasting a lot of money. And the other direction is the flow of power coming back to the grid, which is creating imbalances in the grid, because 1 minute it shoots up, next minute it disappears, and it is stressing the grid infrastructure. Over the time, that infrastructure is going to prematurely fail. So how can we inject technology in it to optimize the grid operations and improve the reliability going forward?
Right. And we should talk about the scale of the challenge, because if this was a small infrastructure, it'd be easier to get our arms around this. But can you talk just real briefly to the scale of on a global basis or national basis, what are we talking about here?
Oh, so I think look at that from a couple of points. One big is that how big the power grid network is worldwide. I think it's 26 million miles of power lines worldwide. Okay. And what's like a 1.6 or 1.7 billion customers utilities have worldwide. Okay. And as these renewables penetrate more and more all across the globe, it is going to make the challenge for the utilities. And I think the other thing is coming is the regulatory burden on the utilities. Okay. I think in future, utilities will be benchmarked against how much renewables they are helping to the grid to utilize it. Basically, increase the utilization of renewables. And that can only happen if the grid gets smarter. And what I call it that a grid will become a grid of microgrids. And inside a substation, each feeder will act like a microgrid because it has customers connected to it. Some customers are generating more energy than what they can consume, and that power is coming back to the grid. And how your grid is going to maintain it? Like my house in California, when it is a sunny day here, I generate more energy than I can consume. Where that energy is going back to the grid. And there are 20% of the homes in my neighborhood have a solar on them. They're all putting the energy back to the grid. And think about that number goes to 50%, 60%. What's going to happen? Too much flow of energy coming back to the grid, and grid has no mechanism to maintain it right now.
Interesting. And on top of the variability in sourcing and transient sources of electricity, we have other wide swings happening as well. Like we have wider and wider weather patterns now, which cause huge utilization. And certainly, Jason, you live in Texas, who is certainly a topic of national and global news very recently. So talk a little bit about, talk to your experience there.
Yeah, I mean, so obviously Prithpal, is describing a lot of these macro trends and the fragility of the grid was certainly exemplified a few weeks back, here in Austin, or Texas, broadly speaking. A couple of things. One is just the grid and the infrastructure itself and its aging and challenges there. And then also issues around deregulation and, how do you operationalize utilities? So first and foremost, I mean, in Texas, I think a lot of people know in the tech industry because we're all working remotely and we're meeting people, and a lot of people have been telling stories about what happened in Texas because they had calls. But if you hadn't heard, basically everything started shutting down. We had record low temperatures. I think the low on one of the days was 5, and the low typically at the worst case is like 15 degrees Fahrenheit. Most snow since 1949, through the region, and basically the grid. A lot of parts of the grid started to fail, just shutting down. Well, then they had to shut more stuff down because they were having a problem with overall power. So they did rolling blackouts. Fortunately, we never lost power at our house. We're in central Austin near downtown, but because I think we're on some critical infrastructure, same grid. But meanwhile, across the street was dead for a week. People were without power for days. Also, water became a problem. All these things, but the word on the street was that we were within a minute and a half or so of the entire grid in Texas failing. And it's all about, you got to keep it above 60 hertz. And as things started kind of coming offline, that it was pulling back, and there was just like the trajectory was, if we went a little bit further, everything would have shut down. It would have taken like weeks to get it back online. And so it was a pretty major situation. And then the stories were, for those that were not regulated, we're on the city of Austin's utilities, but people that were not regulated, going with private utilities, they were getting bills for like $16,000 was the word, and just because that megawatt price went to $9,000 an hour, something like that. So just crazy things happening, and it's just an example of how the grid is aging. It's also an example of how it's, as Prithpal really elaborated on, it's a very, very tight ecosystem that has implications. When one thing goes wrong, it catapults to other stuff. So it's interesting. Certainly a case study on what can happen and how fragile things can be, literally in a matter of days. The last thing I'll mention is, on top of what Prithpal was saying, is there's the technology, but then there's also it's the business model with utilities. If more and more people produce their own energy and especially store it and become more self-sufficient, to a certain degree, the economics of operating a grid fail. And so then you got a whole other world of problems. And so the whole thing, is a fragile ecosystem today that we need to drive more intelligence into, to avoid the issues that we were seeing here. A little more intelligence around, how you shut stuff down and bring it back online. Like in Texas the other week ago. All of the above are just case in point why we need more intelligence through the grid as we modernize things.
Yeah. There's a good side point there that I think if you're not in the power industry, and I'm not deep into the power industry, but we don't necessarily appreciate that when we have rolling blackouts there, that's to protect the grid. And it's not simply just shutting off a breaker, so to speak, or the consequences aren't just, hey, we're turning off power and turning on, a light switch again. It's if you did hit that critical point where the frequency got critically low, all of a sudden massive CapEx equipment starts to be damaged. And if you hit that point, you would probably still be, Texas would still be in the dark today. This wouldn't be a matter of days or weeks. It could be months and months of reconstructing power equipment.
Yeah, the problem they had was once they shut people off early to protect the grid because things were failing, like because of the temperatures dropping so fast, they couldn't turn it back on, because if they turn it back on, it would fail more. And so people that were unlucky to be part of those parts of the grid were just out of power. One of my friends sent me a picture. He's like, hey, I got a new refrigerator, and it's all his food on his counter. And I'm like, hey, that looks really spacious, because his inside of his house was 40 degrees.
Yeah. So Prithpal, maybe you could take us towards the future here. Talk to us about the solution. How do we handle this much more varied, distributed, and transient grid that we need to support?
So I think we got to go onto the drawing board and rethink about it. And what we think is going to be forward, the substations of the future are going to become a critical infrastructure. Of course, they are a critical infrastructure today, but they will become a more intelligent system going forward. So in order to do that, we got to think in like a couple of ways. First thing is that the modernization of automation and control is critical going forward. Okay. We need to modernize. As Jason mentioned, the aging infrastructure. If I'm correct, average life of a substation in US is 40 years. It is not designed to handle the needs of the modern consumers. The second thing is the cybersecurity. As system is becoming more distributed, threats are always emerging there. How to build a infrastructure which is scalable and we can secure it, because today's best security software might not be the best tomorrow. Okay, and it needs to be upgraded one notch up. That's what we need to do it. And the last thing we look at is the analytics. Can we use the power of analytics to get more visibility into the data at the edge of the grid in the substation, extract intelligence and make it data driven? So how do we achieve this? I think the best way to approach it, to look as a data-centric approach. Can we build a micro data center in the substations where we separate the station bus and process bus? Let's start with the station bus. We start virtualizing all the applications on the station bus into this scalable infrastructure, a cluster of rugged servers, which are certified to IEC 61850-3 class 2. Then we have a infrastructure sitting on software infrastructure sitting on the top of it. And then all applications can have their own environments to run into it. What comes out of it is the very highly reliable, secure infrastructure, and gives the utilities the capabilities where they can converge all the data, or in other words, aggregate all the data at the edge, and then apply the power of analytics, machine learning, AI technologies to start extracting that intelligence. I think that's the first step utilities need to do it, because by doing that stuff, now we have a complete visibility into the system. So the next step, we jump into it on the process bus, because we need to embrace standards. Okay? And the process bus, all the protection and control equipment, they need to go through the same journey, because today utilities might have products from 3 different vendors, okay, which are 3 separate hardware. Each vendor provides its own tool to configure it. Okay? And now you have this, and you have to maintain the spares, you got to train the people. And think about a data center where everybody was selling one box with their own application. A guy who is managing the data center now has to basically go through one box at a time. It's not possible. But with this new standardized approach, where we can have that standardized servers and software infrastructure applications. A single tools can be used to configure, provision, deploy the applications. And what it does that it makes the life for utilities much simpler going forward. So I think that is the future we need to go.
Yeah. Thank you, Prithpal. And certainly on the Advantech side, we've been building and continue to build, industrial computers like our ECU 4000 or new ECO 579, which are, IEC certified for these hardened applications to go in that setting. But a key technology there that you mentioned is virtualization. Jason, this is deep into your territory. Can you give us a little bit of perspective of what virtualized applications means in this setting?
Yeah, I mean, and kind of the parallel applies in all markets, but it's certainly very, very valuable in the utility space or energy space. And it's to the point, Prithpal is like, historically a lot of these solutions, they're very siloed, they're sort of hardware defined solutions. You're very set on one vendor as part of that. And the whole notion of, of course, you have to maximize uptime. You have to maximize safety. This is the bottom line. Things go boom in the process industry if something bad happens. So not good, or Texas happens. So you've got to protect those types of things first. But the more that you can decouple your data and your applications from the underlying infrastructure, the better off you are, and especially open infrastructure, because then you can you have more interchangeability between applications. And so this whole notion of virtualization, where you separate that hardware investment, servers in your substation, it could be compute out in the field for demand response or charging stations or whatever. If you unify on this architecture where you've got an abstraction layer between the data and applications in the hardware below, you can now start to transform how you do things while also using existing investments. Because you can't just like switch everything off and start up all fancy new modern containers. You have to be able to move over existing applications. You say something's running in Windows or whatnot today in your substation, you want to put it on modernized infrastructure, server, virtualized, but then maybe you're trying to deploy new types of analytics that are in containers for machine learning or something like that, to look at what's the patterns that are happening to kind of figure out any potential anomalies or optimize the power grid. If you invest as a utility today in this infrastructure that we're all working on as technology providers, it gives you a transition path in what you're doing today. Do it right from a security standpoint, because you have to protect the process and customers first and foremost, but it in doing that, it gives you that path towards modernization. And that's the thing, is as long as you invest in it, the right infrastructure today from a digitization standpoint, you can make it a journey. You don't have to do it overnight. And I think a lot of utilities, a lot of people in all markets are concerned about taking that first leap, because they don't want to take a leap of faith off a cliff. But if you invest in open standards, if you invest in technology that there's a shared investment, this is why we're so heavily involved in open source from a Zadita standpoint in our foundation for orchestration of this type of infrastructure. We orchestrate stuff from the cloud, help you enable your choice of workloads, hardware applications, etc. The reason why we did open is because if you want to evolve into a broader ecosystem, if you want to try to balance all the things we're talking about in the energy space, for example, you have to have some sort of neutral aggregation point in infrastructure. Lots of different stakeholders coming in. You've got public and private. You've got regulations. If you don't have that open, abstracted infrastructure that this open virtualization approach provides, it is very difficult to address the fragile grid. Because you have to do it point by point. Right. So anyway, so virtualization is a big part of it. And then the last thing, speaking on the open side is, I've been working in the Linux Foundation through a variety of projects. EvoS from Zadita, we put that in there. Think of that as like the Android of the edge, so to speak. We're also working in LF Energy, including with Intel and Advantech and a number of others. But LF Energy, another effort from Linux Foundation, where it's like, hey guys, as energy providers, let's band together to stop reinventing the base, so we don't do undifferentiated heavy lifting. Let's come up with some baseline standards around, including code, And then it will not only enable us to invest in the right places versus reinventing, it'll also help us to better be better equipped to exchange data in a transparent fashion. Because a lot of providers also don't do new things because they're scared of IP loss, or they're scared of regulations, whatnot. So if you band together around the basics, it makes it less daunting to accelerate on some of the the more advanced stuff. So it's just really important to have open collaboration around that infrastructure component and to do standardization as much as you can.
Yeah, and on an infrastructure this big, really simplifying that edge architecture is so important. And I think just to reiterate the virtualization factor is, the way that's done today in these substations and such is we have all these dedicated hardware appliances, right? So one piece of hardware, proprietary, dedicated to a certain function. Each has to support its own configuration and such, for each site. But today, just like we've done on our phones, right? It's become an open platform where we can put all these applications and virtualize different applications there. So a lot of these hardware appliances can be simplified and reproduced in software and deployed, on an edge CPU.
Yeah, so I think exactly, Mike, what you said. What is the outcome of this approach? Once you have this hardware and you have this layer built into it, what utilities can get? High reliability. For example, you have a stack of 3 servers, you have virtualized your station bus on it, and one server fails in the middle of the night. No problem, because your system will keep working as it is, okay? And you can send somebody next day when his time is right, go replace it. Or you are end of life after like a 7-10 years, you have end of life and you need to replace these servers. No, you don't need to shut down your system, substation down. You can just go replace one server at a time and your applications will be running, all the time. And then also the other thing is the manageability. In order to deploy a new application, you can do all that sitting from your control center. Again, create a virtual machine or container, put the application into it, then let that application run, collect your log files, analyze them. When utility feels comfortable that it meets all their requirements, bring that application online, and you can avoid all those costly trips to the substation, So I think based on our work with the utilities, we saw that around 76% reduction in operation and maintenance cost.
Yeah, it's a massive simplification once you get past, kind of that initial step. There's, of course, regulations involved as well. We've seen, at Zedita, actually really good traction in renewables because it's a newer space and there's less regulation. Not to say regulation is bad by any means. It's just there's not as much inertia around current solutions. It's not as old as the current grid and some of the practices there. But so that's key part of it too. And the other thing I would just add, so definitely massive opportunity to modernize substations, kind of the core utility functions from transmission down through distribution and all that. But also because it's an ecosystem, because there's a very tight relationship and we've got, traffic flowing upstream instead of downstream. It's almost kind of why we need edge computing. It's like when we get services from the cloud and then all of a sudden everyone's creating data and we're pushing it to the back end. It's the same parallel. You've got to push more compute out to the edge for the same reason you got to push power smarts out to the edge because you can't handle the upstream. But that same intelligence we need to push out into the field. For example, demand response. Zedita, we're working with a customer that they own the utility. They're the utility. They deploy boxes out, at their customer sites, manufacturing plant, building, otherwise. Part of the challenge for them, number one, today demand response is like literally often I call you up, hey, can I shut the power off now? Yeah, cool. Shut it off for an hour. You need to make that more automated, negotiated intelligence between the transmission and the building. But and the other problem that they face is that if I'm a utility and I'm going to put intelligence in that building for demand response to kind of optimize my operations, shut off the grid when I need power, I have to today usually run a T1 line out to that location with cellular backup for communications to make sure it's there, because I have to also deal with the stakeholders within that building. Like I can't run on the building's network because I'm a utility, I'm a third party. These are all the complications beyond all the many other complications. So Zedita, since we virtualize things, we also offer this zero trust security model in the field. We can help you orchestrate a box in your environment. The utility owns the box, but it actually runs on the IT network because distributed firewall can back data back to that utility and make sure it doesn't get mixed up with the customer data. And that's important because the utility today is paying $300 to $1,000 a month for that T1 line. And so if you can get rid of that line as part of your service, it's a massive savings for the utility. And the same thing applies for all of these different levels of compute, and whether it's the substation or elsewhere. It's not just about the intelligence, it's about how do you deal with this heterogeneous nature of the edge, the heterogeneous nature of these types of ecosystems. You have security that works across mixed boundaries. And that's that domain response example is case in point. We're seeing a lot of interest in technologies that can help with that.
Yeah, excellent. And yeah, anything at this scale, I mean, anything you do, the multiple factor is enormous. And to Prithpal, your example of, operations and maintenance costs declining by 76%. I mean, that is, usually people talk about, gains of efficiency and you're looking at 2 or 3% at a time, but to talk about, 3/4 of the cost being eliminated. And that's on top of, that's on top of the CapEx reduction as well, right? Because I believe there's a pretty significant reduction in number of devices and kind of redundant devices, if you will.
Yes, Mike. Again, our work with one of the utility, we found out that 50% reduction in devices happens with it. So the biggest thing is that now you have multiple boxes. You have to keep multiple spares for them from multiple vendors. If we standardize to a rugged servers, now a rugged server is a rugged server, whether you put in a generation substation, transmission substation, or distribution substation. Only will happen somewhere you will put 2, somewhere you will put 5, depending upon the size of the substation. So it is all standardized. So that also saves huge capital cost for the utilities because they don't need to keep multiple boxes in spare,
Right, yeah, and I mean, it lessens the skill sets required once you consolidate on open infrastructure. You use virtualization, cloud native principles as much as you can. Then you apply necessarily unique hardware, software, and services to that more consistent foundation, and then you can support different use cases as you go. Of course, some are more latency critical, mission critical than others, and you might vary the tools a little bit, and so there's definitely some considerations there. It's not like it's one size fits all completely. If you've got critical protection equipment, you're going to want more real-time operating systems and things like that. But everything else, you can generalize it and make it way easier. One thing I'll say just came to mind is like, depending on the use case, we had an event a while back where we brought in a bunch of different providers, and it's just interesting about the needs across the market. A guy from the U.S. comes up and he's talking about how he's been using IoT at the an edge for addressing their customers' needs, and it's like, well, we've been saving the last 5% out of the power grid, or 5% efficiency, and then a guy from Malaysia comes up and says, I just want to have power, completely different mindset. And so the same infrastructure could address either one. It's just depending on your needs, you apply it in different ways. But that just really stuck with me. Yeah, that's a different problem, just having power. Kind of like us in Texas a couple weeks ago, but still, it's important to invest in that common foundation.
Yep.
Yeah, absolutely. And to be able to standardize, if you look at the complexity of a substation today in terms of number of devices and physical footprint, and to be able to standardize that onto a virtualized environment, and to a large degree, Jason, it addresses something you said of having more success in like the renewables, where there's a little bit quicker to adopt some of these things. But even better yet, if we can standardize a footprint and say, this works in a substation, it looks in a generation plant, whether that's traditional or a renewable, And some needs change. You need more redundancy and maybe lower latency, but the fundamental architecture can stay the same. And when you look at a problem this vast, I mean, if we can't solve this problem in 5,000 unique ways and manage it in 5,000 unique ways, it's got to be really buttoned up and boiled down into some standard architectures.
Exactly.
That's called whack-a-mole. If you do it that way, you got to have one way. Sorry for the
Yeah. No, I think that's right. We use the same standard in substations. We can go apply same inside the wind turbines. We can take same architecture, apply to the microgrids. Applications will change depending upon the use case, but the infrastructure remains the same. So I think that creates that volume towards the standardization, bring the cost down for everybody. In the whole ecosystem wins in that. So I think that's the direction we need to move. And that's what happened in data center world. That's what happened in the telecom market. And I think utilities are also ready for that transformation.
Yeah, we're seeing this across all the markets. I always say, open builds a bigger stage for a better show.
Yep.
Exactly.
Great. Yeah, well, that's a great point to wrap up on here today, guys. And I thank you both so much for joining us here today. This is an enormous topic and an enormous challenge, but I look forward to seeing what we can all do together and in this whole ecosystem to take this on.
Yeah, awesome. Thanks for having us on, Mike.
Thank you. And thank you, everybody, for watching. And as always, for more information on any of Advantech's products, contact your local Advantech sales representative. Thank you, everyone.